So regenerative medicine is very personalized. There's not one bullet that fits all. Really what you need to do is take into account the individual status of your patient and make a decision from there.
Welcome to the Regenerative Warrior Podcast, Doctor's Edition. One of the fastest growing regenerative medicine and anti-aging podcasts in the world. Each and every Tuesday and Thursday, I talk to the top experts to show doctors how to market, manage, and magnify their practice to help more people and make more money. Each episode is short and to the point without wasting your time with pointless conversation. Learn the skills to be successful without traveling to seminars or paying for expensive consulting fees. Are you ready? Because I am. I'm Dr. Ross Carter, and it's time to start the Regenerative Warrior podcast now. Two things before we get started. The views expressed by our guests are not necessarily those of Dr. Carter or this podcast. One of our podcast partners has just announced special pricing for our listeners. Wharton's Jelly Allograft for $475 per cc. You heard that right, only $475. White papers are available. This is for a limited time, so act now. Why pay double or triple the price from other providers? To learn more or to order, text your name and the word JELLY, Jelly, to 561-962-1231. Write that down. It's 561-962-1231. On with the show.
My name is Dr. Ian White, and I'm the Chief Scientific Officer.
So today, I thought it would be a great idea. A lot of doctors who are just tuning in probably are new to the field of regenerative medicine and stem cell therapy, and probably are a little confused about what it really is. And I think we need a basic education about this type of topic. So could you maybe talk on that today?
Yeah, definitely. This is a topic that I've had a lot of success with at a lot of the big conferences recently. I was at Boston recently, and we thought that was a very good idea, the place to start and give everybody a strong foundation into regenerative medicine before we get into the nitty-gritty to try and unpack exactly what regenerative medicine is and how it's being used in the clinic. So what I like to typically talk about is how homeostasis differs from regeneration. So we as human beings typically live around 80 years to 100 years, but every minute of every day you're losing between 200 and 300 million cells. And those have to be replaced somehow, or else you'd be dead. So those cells typically come from stem cells. So there are stem cells throughout the entire body, and they're constantly turning over tissue. There's definitely a lot of controversy right now whether there are cardiac stem cells, but a lot of my research has been focused on cardiac regeneration, and what I've found and what is consistent with the literature is that the heart actually has a different mechanism of regeneration and repair, and that's mediated through the epicardium, which is a single layer of cells around the heart. And so it doesn't actually seem to recruit endogenous stem cells. There's actually a different repair mechanism involved there. But for the most part, all other tissues have a stem cell niche, and those stem cells are what are required to maintain that tissue. And so how does homeostasis, the day-to-day maintenance of your cellular components of your tissues and organs, differ from regeneration? Well, regeneration is what happens after an injury. So when your body is injured in some way, if you cut your skin, there's an immediate regenerative response. The first line of defense is to block that hole, and so you get a scab formation, but you also recruit a lot of blood cells, a lot of hematopoietic progenitors, stem cells, and other cells that then act to rebuild that tissue. And so in regenerative medicine, we try to utilize the body's own ability to repair to induce regeneration in chronically injured or acutely injured areas that are having trouble themselves repairing.
Why are they having trouble?
So for the most part, it's to do with aging. Okay. So as we age, our demand for stem cells increases, but our pool of available stem cells decreases.
So we have more things that need to be repaired with less repair things.
Exactly. The things that do the repairing are becoming in short supply, but the demand for them is increasing. And that's why we age. That's why our hair goes white. That's why our skin loses collagen. That's why we have all of the symptoms of aging, because stem cells are reducing in number, but the demand for them is increasing.
So in theory, if we increase the amount of stem cells that we had, could we prevent aging?
So one of the really interesting observations that have come out of the field of regenerative medicine recently is this idea of parabiosis. And parabiosis is something that has had a lot of focus at Harvard University recently, where they were able to take two mice, one young and one old, and connect the blood supply. And when they connected the blood supply, and so the two mice were now sharing the same blood, the old mouse started to actually get younger. The hair started to grow back, the color of the hair started changing, markers of aging in the blood started to decrease. And so the stem cells from the young mouse were having a positive impact. So, of course, we can't connect ourselves to a young human. We can't just go to the store and buy a baby and hook ourselves up.
Right.
I don't know if that's appropriate for the podcast or not, but
yeah, I don't think that would work.
No, that would not work.
It's an interesting theory.
But there are many people out there that have the resources and the means that do get infusions of stem cells on a regular basis in order to fight symptoms of aging. Of course, most people can't afford to do that, but a lot of people do take advantage of stem cells and regenerative medicine when they have an injury. So, for example, as you're aging, maybe you're 40, 45 or older and you damage your knee, a lot of the tissue in your knee is white tissue. And the reason it's white is because it's not perfused by blood. Muscles are very red. They have a huge blood supply. They repair very easily. But a lot of the tissues in the knee and other joints are white. So they don't have the blood supply in order to bring cells in and help regenerate. So as you get older, those stem cells that would normally work in your knee or other joint are starting to poop out and senesce. They're getting old. We can actually supplement those with other cells. So perhaps we can concentrate some from your adipose or your bone marrow, or what's becoming much more popular now because the technology is starting to catch up is the use of allogeneic cells. So cells from another individual. And that individual, for the most part, is umbilical cord blood derived. So we're taking umbilical cord blood and we're isolating from that hematopoietic cells and other cell components, including stem cells. And we're using that as cellular therapy for tissues that are having trouble regenerating on their own. And we're able to give them a boost. We're able to give them an additional source of energy because a lot of stem cells are able to contribute and donate mitochondria, which are like the battery pack of cells. So if your cells are senescent, if they're not able to keep up with the demand, allogeneic stem cells are able to donate mitochondria to get them going, to give them a boost. But these cells also initiate a very strong regenerative response. They are able to modulate the inflammation and induce regeneration in that tissue and grow new cartilage, if in the case of the knee, or they're able to help grow new tissue.
So that this becomes a kind of a controversial topic, right? Where we've had people say that an allogeneic product or a tissue from somebody else doesn't actually have any live cells. Is that a true statement, or what is that?
Well, there's definitely a lot of truth in that. I can only speak for myself, but I've definitely tested a lot of other products out there. And what I found is that many of them have not been prepared correctly. And when you actually test them in an appropriate way, you find that they are very limited in cells, or in many cases have no live cells at all.
So there is truth in that.
There definitely is. It's not across the board though. So in my case, I've been working in the field of stem cell biology and regenerative medicine for over 20 years.
So you're not a medical doctor.
I'm a PhD.
So you actually use these like with research and things.
So for 20 years, we've been using stem cells in the lab to try to understand the regenerative processes. My expertise is with cardiac regeneration, but we still have to understand the basic biology of stem cells in order to be able to work with them. And so with that knowledge, with that expertise, I was able to make a product that actually is able to withstand the freeze-thaw cycle. And we're able to actually manipulate the freeze-thaw cycle in a way that's actually much less harsh on the cells. A lot of other companies don't have this technology because they're not trained in stem cell biology.
Well, that makes sense. So really what happens is the cells die because of the freezing process and the thawing.
Exactly. So it's not just the freezing process, it's also the thawing process. So if you don't prepare and handle the cells correctly before you freeze them, while you freeze them, they become very sensitive to the freezing process. Also, if you don't use the right protocols to freeze them, you can kill the cells immediately. And then on the other side, once you come to thaw the cells, if the cells haven't been prepared properly, if they haven't been cryopreserved properly, once you thaw them, there's another round of very high attrition that if there are any remaining cells, they'll be killed off by the thawing process. So for many, many cases, in many companies out there do not understand and have the technology in order to keep those cells alive through that freezing and thawing process.
Now, how does a doctor that is just getting involved in this and they're like, I'm a doctor, I don't do research or testing, how do they know what to look for when they're considering using a product, or in your case, a cord blood product?
How do they know what to use and what's safe and what's real and how to know what to do?
So that's one of the toughest questions to answer because, of course, you can't just ask any one person because everybody has their biases. But one of the things you can do, you can go to meetings like Boston BioLife. There you have experts in the field talking amongst themselves, and you can ask multiple people, multiple questions, and try to get a consensus. What is it that people are using? Where are they having successes? The other thing you can do is demand data. So we have a white paper that was prepared using our cells. So this is a third-party independent analysis of your cells. You take a lot from your storage, you send it to them, and they process it without any third-party bias. It's an independent study. And if you're a physician and you're looking to find the best products, you can demand that data. You can ask to see the white papers. They're usually freely available. If a company won't share that data, then walk away. Many companies do have that data and they do share it. And so what you're able to do, especially if they're prepared by the same third party, which many of the top league manufacturers use the same company. So you can compare apples to apples this way. You're able to see directly what the viability is of those cells post-thaw, and you're also able to see what kind of cytokines and other proteins are in those cells. What are they producing? And not only can you see what they're producing, but you can see to what extent, what level. So if you have a very poor batch of stem cells and they're dying, they're not going to be very metabolically active. They're not going to be producing a lot of IL-1 receptor alpha. They're not going to be producing a lot of anti-inflammatory cytokines. But if they're very robust, if they're very strong, if they're very vital cells, you'll have very high levels of these cytokines and growth factors. And that's the case with our cells. We have very high viability post-thaw, and we have very high production of anti-inflammatory and pro-regenerative cytokines and growth factors in our cells.
So I've also heard that some naysayers, I guess you could say, have said that it's illegal to use a stem cell and put it in someone's body. Is that accurate or is that not accurate?
So those of us that are serious about this industry and trying to make this industry move in the right direction are trying to work very closely with the FDA to help educate them, help educate our peers on what it is that we need to be doing in regenerative medicine. There are a lot of people out there that don't seem to care for rules and regulations, and they're cowboys and they're flying by the seat of their pants and they're causing a lot of trouble because they're hurting people. What we need to do is we need to do it right. We need to apply for IRBs. We need to have INDs. We need to.
What do those stand for, by the way?
So an IRB is an approval from an internal review board. Okay. And so this is a review board that has approval from the FDA to review applications for INDs, which is an investigational new drug. Okay. So most products that are derived from the body that are processed would be considered a 351 product, which is regulated differently than a 361. So those terms are a little bit complicated, but to keep it simple, basically one is considered a natural body product with no processing, and the FDA regulates that different than what they would consider a drug, which would be the 351, which is they would consider to have been manipulated or being used in a non-homologous way, which means not for the natural use of the cell or tissue product. So what we're trying to do is apply for INDs with our cells and demonstrate not only the safety but the efficacy of these products, and then demonstrate that these cells have a broad range of effects on multiple different indications. And that's very expensive, it's very time consuming, and it's a major barrier for entry for a lot of people. And so a lot of companies out there, a lot of the smaller companies, are just skipping over that. They're ignoring the fact the FDA exists, and they're just moving straight ahead with doing anything they want in total disregard of the rest of us in the field that are trying to do it right.
Sorry for the interruption again. To find out more about this speaker, become a speaker on our show, have Dr. Carter present at your event or podcast, learn more about coaching, consulting, tissue allografts, exosomes, supplements, legal help, or how to create $1 million business card and dominate your area, we're here to help you. Just text your name and any question to 561-962-1231. Write that down. That's 561-962-1231. Or go to our website at drrosscarter.com to learn more. Don't forget about our current $475 orange jelly special. On with the show.
So in the regard of using live cells, it is legal to be able to do them with stipulations, right?
So if you're working under an IRB approved protocol, then you can use the cells in an open forum. Now, if you're working off label in your own clinic, then that's a completely different matter. You can purchase cells from anywhere you like to, using them off label in the clinic under your own guidance, and there's no oversight for that at the moment.
I gotcha. When you're using a product like that, is it just the stem cells that are causing the reaction, or what is it that actually causes the process to occur?
So a lot of people out there are a little bit confused about that because they think that the purer the stem cell product, so the more stem cells and fewer of any other cell you have in, would make a better product. That's not necessarily true. Because when we're in the laboratory and we're doing stem cell transplants, we actually mix those stem cells at about a 1:9 ratio with what we call buffer cells. So these are cells, hematopoietic cells, hematopoietic progenitors, mature cells, and these help buffer the stem cells. They help protect them from the environment, but they also contribute pro-regenerative activity as well. So the stem cells have a very robust job to do when they are injected into an area that requires regeneration. But the cells that are with them also contribute to modulating the immune system, to helping transfer mitochondria, a lot of different activities. And that's typically what's in these perinatal products like umbilical cord derived mononuclear cells. There's only typically between 1% and 3% MSCs, mesenchymal stem cells. The rest are not stem cells. They're progenitors, they're mature cells, but they all contribute to the regenerative process.
And they do that by giving energy, like the mitochondria, like you'd mentioned, and they buffer and they protect it?
Yeah, so in an environment that's hostile, a lot of cells, if you just inject 20 cells into an environment, they're likely to die because the immune system will start vacuuming up some of those cells. But if you've got those 20 cells and 1 million cells, like buffered by 1 million cells, the chances that the immune system is going to just start vacuuming up those 20 stem cells right away is very, very small. So these umbilical cord derived cells are what we call immune evasive, means that they can avoid the immune system for a while, but they can't avoid it forever. But if you buffer them with additional cells, the immune system takes longer to get to them.
How long do they last? And also, are they engrafting?
So that's a great question. A lot of people believe that they only last hours, but in our experience coming from the laboratory, we see that they last between 1 and 14 days. So it's typically between 1 and 5 days, but they can last up to 14 days. We can still find them. And the way we find them is we trace them. We tag the cells with a tracer, and then we're able to, after the fact, look where in the body those cells are. And one of the locations that we typically find cells is the lungs. We also find them in the liver, but then we also find them at the site of injuries. So if the patient or the subject has a wrist injury, we're able to find the cells in the wrist too.
Did you have to inject it into the wrist? Or?
No, this is IV. If we give the cells IV, they go throughout the entire body. A lot of them get sequestered in the lung. A lot of them get sequestered in the liver, but there are still a lot of cells that make it to the peripheral sites of injury. So a lot of physicians might inject directly into the knee if it's a enclosed environment, so the cells will actually stay there. If you're looking for some sort of systemic help, the cells will go around the body and they'll actually express adhesion molecules and stop and stay in areas of regeneration and try to help that regenerative process. But eventually the immune system will catch up with them, and after 1 to 14 days, they're eliminated from the body and they don't engraft.
So they never engraft. So the cells are never creating tissue. What about that?
So allogeneic cells don't engraft and they don't generate new tissue from those cells. They can help generate new tissue from endogenous cells by helping ramp up the regenerative process, the innate regenerative process. So they can induce collagen formation. They can help induce other pro-regenerative programs, but they themselves do not differentiate and engraft into the tissue.
Can it create new tissue?
It can create new tissue, but not directly, it's indirectly. So if we want to generate new tissue in, let's say, the knee, if we want to generate new cartilage, we can take autologous cells from the bone marrow or from the fat, and we can mix them with exosomes or umbilical cord-derived mononuclear cells. And those allogeneic cells will help the aging autologous cells to do their job of regeneration, to generate new cartilage.
Well, where does the cartilage come from then, if you killed off the cells?
So if you're taking MSCs from adipose or from bone marrow, those cells have a trilineage differentiation capacity. So they're able to, under the right conditions, differentiate into fat, bone, and cartilage. And so if you're injecting them into the knee and there's a clear need for cartilage, then those cells are able to differentiate. Your own adipose cells, your own bone marrow cells are able to differentiate. They're able to change into cartilage tissue. They're able to undergo chondrogenesis.
Well, if that's the case, then why would you use an allogeneic product when you could use your own body's cells that actually create create new tissue.
So if you're a 25-year-old athlete, then definitely your own cells are probably going to work extremely well. And in fact, in our clinics, we often do that kind of procedure. But if you're aging, if you're over the age of 40, if you're approaching 70, let's say, your own cells aren't going to have the same regenerative capacity that a young individual would have. And so the regenerative capacity of those cells can be enhanced through the addition of something like exosomes or mononuclear fraction cells. So the mononuclear fraction from umbilical cord blood. So a lot of people call those kinds of cells cord blood derived stem cells, but it's not just stem cells. There's 1 to 3% of stem cells in that product. And so I prefer to call them mononuclear fraction because it's the mononuclear fraction that we remove from the cord blood that contains some stem cells.
Okay. So if you're an athlete, it's probably better to use your own cells. But once you get, middle age or so, they're not as effective.
Right. Or if you have an immune issue, if you're immune compromised, or if you have an autoimmune issue, if there's something wrong with your own cells, then using an allogeneic product is a much better idea. So if you're aging, if you have an issue with your own cells, then allogeneic products are the way to go. If you're young, if you're healthy, if you have good bone marrow, good adipose, then using your own cells is going to be a very potent way to regenerate your tissue.
And how do you know what type of allogeneic product to use? I mean, there's amniotic fluid, amniotic membrane, cord blood, cord tissue. I guess that'd be called Wharton's jelly. How do you know what would be the best for your condition?
So regenerative medicine is very personalized. There's not one bullet that fits all. Really what you need to do is take into account the individual status of your patient and make a decision from there. A lot of the perinatal products are very, very different, and not all of them are as effective as others. Some people prefer to use only autologous cells because that's what they're comfortable with. Some patients don't want to receive allogeneic cells from another person. So you need to have that in your regenerative arsenal. You need to be able to offer both allogeneic cells and autologous cells because you don't know what your patient's going to want. Also, there are different price ranges. So something like amniotic fluid, it doesn't contain live cells, but it contains a lot of exosomes and a lot of pro-regenerative factors, growth factors. So it's very cheap and it can be given, but it's not quite as effective as pure exosomes. It's not quite as effective as umbilical cord derived product. So it depends what your patient can afford. It depends what you want to administer. And it depends what your expertise level is. Like I said, harvesting, freezing, thawing, and then using umbilical cord derived cells is quite challenging. If you don't want to be involved in that process, you want something much more simple. Amniotic fluid is the most simple you can get. It's just a fluid that is removed, it's filtered, and then it's injected. So it's a very simple product. So really what we are trying to do here is have a very broad toolbox, make a lot of different products available for the physician and for the patient for them to decide what's the best approach for them.
But if they don't know if they should use an amniotic fluid or Wharton's jelly or cord blood, for example, how do you know if you have a condition which type has the most beneficial outcome? Right.
So that's the job of the physician to become educated. So this is a very dynamic period where we're learning a lot about regenerative medicine, and now physicians are starting to become a lot more interested. But the information's out there. They just need to find it. So they need to go to conferences. They need to learn. They need to talk to their colleagues, their peers, and they need to talk to people like me. You know, they can call me on my telephone. They can email me and ask me specific questions. I can't give them advice on how to treat a specific patient, but I can let them know about the biology of stem cells. I can let them know what's different between this product and that product. I can tell them the difference between Wharton's jelly MSCs and amniotic fluid. So I can give them that information. They just have to go out and find it. There's no other way to do it. You know, there's no forum a doctor can go on and instantly learn everything about regenerative medicine. I've been in this field 20 years and I'm learning every day. So I come to these conferences to try to help others understand. I give presentations, I hold workshops, and I try to impart knowledge that has taken me 20 years to accumulate over the course of maybe 4 days. This is a way that physicians can find out this information. It's a very complex area, but if they're going to do it, they need to be educated. They can't just assume that going to a website, hearing a review from one person will be enough for them to just treat all of their patients. They need to become extremely educated in this field.
And a lot of doctors are not educated in this area.
A lot of doctors that are actually trying to use this technology are not educated. And that's, I think, why we're seeing a lot of negative effects, because they're not taking the time to understand the technology, understand the products, and understand the biological processes behind the regenerative process that they're trying to initiate in the body. You can't just take any old product and stick it anywhere in the body and expect it to be the last thing you have to do with that patient. You know, there's going to be long-term follow-up. There's a lot of rehabilitation sometimes that's going to be involved. It's a very, very intricate and challenging medical strategy, but it's extremely potent and it's extremely effective, but only in the right hands. We have very skilled, very knowledgeable practitioners that have been doing this for a very long time, and we use the top products, and we know how to apply them, and we know how to follow up with rehabilitation and other protocols. If you have more questions, or if your listeners have more questions, this is a great podcast. It's a really great way to find information. But if they do have more information, I'm more than willing to take phone calls and emails, like I said, so they can feel free to get in touch with me.
Thanks for listening to our podcast. Please subscribe to be notified of all new episodes, and also like and share this to help us grow. To find out more about this speaker, become a speaker on our show, to have Dr. Carter present at your event or podcast, learn more about coaching, consulting, tissue allografts, exosomes, supplements, legal help, or how to create $1 million business card to dominate your local area, we're here to help you. Just text your name and your question to 561-962-1231. Write that down. That's 561-962-1231. Or you can go to our website at drrosscarter.com. That's drrosscarter.com to learn more. Until next time, this is Dr. Ross Carter, signing off.